Hello everyone. In this video we're going to go over section 9.7 class note problems. So we're going to work here on the Pascal formula, the Pascal triangle, and the binomial theorem. So first let's go with using the Pascal formula to compute the following combination without using necessarily the factorial formula directly. Notice that we have some values here for what some of these things are going to be, and specifically is because we're using the Pascal formula, which is n choose r is equivalent to n minus 1 choose r minus 1 plus n minus 1 choose r. So if we use this and we represent 7 choose 3, we're essentially doing 6 choose 2 plus 6 choose 3. And since we have those values here, then we just have to add them up, and that's just going to be 35. Similar for this, we have A4. So A4 will be 7, 3 plus, 7, 3 and 7, 4. And we have the values for that, 35 and also 35. So we get 70 here. Okay, so those are some just quick reminders of the Pascal formula and its use. But now let's move on to question number 2, where we'll remember how to do the Pascal triangle, and we're going to check which one is the row when n equals 5. So remember, the building of the Pascal triangle, you can start with like 1, and then you do 1, 1 next, and then here you're going to have 2, and then you're going to have 1 here of the rows. And remember, this is row 0, right? So this is just going to be the row 1, row 2. So we continue. We have 3 here, 3 here. And then we're going to have 1 and 1. And this is a row 3. We're going to have 1, 1 here. And then we're going to have 4, 6, and 4 once again. And this is a row 4. And last, row 5, we have 1 here, 1 here. And then we get 1 plus 4, 5. 6 with 4, 10. 6 with 4, 10, and 4 with 1, 5. So our row number 5 is going to consist from 1, 5, 10, 10, 5, and 1. So that will be the highlighted row for here. So now we can use the binomial theorem to find the binomial expansion of a plus b to the 4. And so remember, the way that this goes is a plus b to the 4. We start with the 4 row, so we can go with 4 choose 0, right? So 4 choose 0, which is going to be 1, a to the 4, plus a to the 3, b to the 1, and this will be 4 choose 1, right? And then we go with a to the 2, b to the 2, 4 choose 2, and then we keep reducing a, increasing b, a, b to the 3, 4 choose 3, and finally b to the 4, 4 choose 4. Once that we have that binomial expansion, of course, this is going to be the numbers that are here on the 4 row. So this is going to be just 4 choose 0 is going to be 1. So it's a to the 4. 4 choose 1 is going to be 4. So 4a to the 3b plus 4 choose 2 is going to be 6. So 6a squared b squared. Once again, 4 choose 3 is going to be 4. And 4 choose 4 is going to be 1, so b to the 4. Okay? So this is our use of the Pascal triangle to do the binomial expansions here. Now, we can do the same type of binomial expansion, but now with something like u minus 2b power to the 4. And in general, we can just see this as u plus, and then we're just going to see minus 2b as our b. And so this is going to be power to the 4. And so what we're going to do is we're just going to apply what we have from before to this one. So this is going to be u to the 4, since u is a, plus 4 times u cubed minus 2v, which is our b, plus 6 times u squared minus 2v squared, plus 4 times u b cubed, which will be minus 2b cubed, plus minus 2b to the 4th. That'll be u to the 4th. And then here we multiply, we get minus 8b u cubed. We have here 4. 6 by 4, 24. So 24 u squared b squared. And then we have this minus 2 to 3. It was going to be minus 8 by 4 is minus 32. So minus 32 u b cubed. And then this minus 2 to the 4 is going to be 16. So plus 16 b to the 4. And that's it. This will be how to use this form to the 4 to calculate this more complicated expansion. If you have to do this without doing this one first, the recommendation is, of course, find first this arrangement and then just figure out what the multiplication with the inside terms will be. You can also use the strategy of directly just relating this to the formula of the sum. So you can see this as the sum k equals 0 to 4, 4k. And so you plug the values right away. So this will be u for minus k, and then minus 2v to the k. That will kind of immediately give you these values right away. Okay, so let's move on to question 5. So in question 5, we want to find a specific coefficient that is indicated in each of the expansions. So we have x to the 6, y to the 3, and x plus y power to the 9. We don't want to go for the full expansion, so we're just going to focus on the particular term that we need. So for example, for power to the 9, you're always going to have something of the form, a coefficient of the form 9k, x to the 9 minus k, y to the k. So the first thing is that we can identify who's the k. So in this case, k is equals 3. And so if k is equals 3, we're going to have the coefficient is 9 choose 3. Okay? Because that's going to give me here x to the 6, y to the 3, right? Comparing this to this. That's what we do. And so we do now choose 3. And so now choose 9 choose 3 is going to be 84. Did you calculate that with your calculator? But the procedure then is the same. So now let's calculate the coefficient of x to the 3 on x plus 2 to the 5. And so the coefficient of x to the 3, you got to remember, if we're doing this x plus 2 to the 5, in general, the coefficients are going to be 5, choose k, and then we're going to have x to the 5 minus k, and then the second number is 2, so 2 to the k. So if you only get x to the 3, right? So you're going to get that k is equals 2, right? Since that will give you x to the 3 here. So you can pretty much figure out that the coefficient is going to be 5 choose 2 times 2 to the 2, because this is going to enter as a number in front of that. So now this is 5 choose 2 times 2 to the 4, 2 to the 2, sorry. And 5 choose 2 is going to be 10 by 4. So that's going to be 40. Okay. So now last, we have a similar one. We have a to the 5b squared. But now we're making an expansion of 2a minus b power to the 7. Okay. So once again, we want to write this in a way that is an a plus b expansion. So this will be 2a plus minus b power to the 7. And so the coefficients of this are given by 7 choose k, and then we have 2 to the 2a power to the 7 minus k, and then minus b power to the k. So now we want to match this two, so they match this here. And so to match that, we need that k is equals to 2, as you can see here from the b. Minus b squared is the same that b squared. So this implies k is equals 2. And so what that means is that the coefficient is going to be 7 choose 2. And we're going to have 2a power to the 5, right? Minus b squared. And so when we plug all this together, notice that this is going to be 25 times 2 to the 5 times minus 1 squared. And so this is going to be a to the 5, b to the 2. So you can see that the coefficient is this 21 times 2 to the 5, which is 21 by 32, which is, this is going to be 672. So that's my coefficient. All right, so question number 6. Let's use the binomial expansion to expand 2x minus 3 power to the 4. We can use the same thing that we did here on the past with the expansion. So notice that this is a and this is b, so we can do a is 2x, b is minus 3, right? And so we can do 2x minus 3 power to the 4. In applying this expansion, this is going to be 2x to the 4 plus 4 times 2x to the 3 times b, which is minus 3, plus, and then 6 times 2x squared times minus 3 squared. And then plus 4, 2x, and then minus 3 cubed plus minus 3 to the 4th. Okay. Now we break all that apart. This is going to be 16x to the 4. And then 2 to the cube is 8. By 4 is 32. So 32x cubed. But minus 3 times minus 3, then it's going to be minus 96. Okay, so minus 96 x cubed. And then this is a 9. 9 by 6 by 4. That's going to be 216 x squared. And then we'll multiply this one here. Minus 3 to the 3 is going to be minus 27. But times 8 is going to be minus 216 once again, x. And finally 3 to the 4, which is 81. So now we managed to have the full expansion here for this term. Normally you'll have to use the 4 choose 0 power 2x to the 4. You need to find the coefficients that are in front first. In this case, because we already had the coefficient from the previous question, then we're using that. But if you're not, then you gotta make the expansion. Let's assume that this is power to the 5. Then you will have to do this if I choose 0, if I choose 1, if I choose 2, if I choose 3, if I choose 4, to find the polynomial. Okay, question number 7. Let's prove that the sum of all the entries, all the coefficients in the row n of the Pascal triangle is equals to the n. Well, this is essentially proven that n choose k from k equals 0 to n is just essentially 2 to the n. But this is true because this comes from setting a equals b on the binomial theorem. So this is just like 1 plus 1 power to the n. This is giving me this, okay? And now, since one side is equals to 2 to the n, then that's why we're getting that this sum is equals 2 to the n. This is not really a lot of special things here going on. All right, so now it says the entry in row n, column R of the Pascal triangle can be interpreted as follows. It counts the number of paths from the top of the triangle to that entry, moving only down left or down right. Explain why this gives in choose R. Well, if you think about it, if we start like let's make a tree here. We have 1, 1, and then 2, and let's make 1s, and then let's make another one, and let's stop here. This has enough. So if we're going, let's say down the right, so if we go right 1, right 2, and then we move to the left here on the third one, what this is telling me is, hey, I move, this is row 0, 1, 2, 3. So what the NR is giving me is, where is ending? Is ending on the row tree. When I'm doing here is, notice that from the row, this is row 3, and this is column 2, because this is column 0, call 1, call 2, and then call 3. Okay, so this is giving me the positioning. So when you have here, when we end up at this number in particular here, we will be having 3, choose 2, because what we do is we're ending on the row 3, column 2, and this is counting at what how many of these paths I took to the right here when I achieve the number that I wanted on the next column. So the number of paths is equals to the number of ways you choose which are of the n steps is right. So notice that because I have 2 paths, 2 rights, that's why it's 3, 2. So this will be equals to 3 paths.